Hello, welcome to Designing Snowflake for Multi-Tenant Data Applications. My name is Kevin McGinley, and I'm a technical director on the Snowcat team at Snowflake. And today we're going to talk about the different options that you have for building data applications with tenancy in mind. So when you build your data application, you have to think about how you're going to build tenancy into your application, what models that you're going to use, and we're going to cover those today. So if you're building a data application on Snowflake, you're actually building a data application on the data cloud. The data cloud is lots of Snowflake customers mobilizing all of their data in Snowflake to be able to do high intensive, high scale calculations, analysis, analytics, and develop and deliver data applications using the Snowflake platform, but also using the great content that comes with the data cloud. Now, I'd like to show this picture as a way to sort of illustrate what that looks like and what that content includes. What you're seeing in this picture here are all the little dots are Snowflake customers, and the lines between them actually show customers sharing data with each other. And this content, this data that can be shared between Snowflake customer to Snowflake customer, really takes the data platform to the next level and makes it a data cloud where, globally speaking, you can run a data application using data from anywhere in the world, from any Snowflake data provider in your application, or you can become a data provider yourself, sharing your data from your application out to other Snowflake customers. So this is really the data cloud that you're building your data application on. So what makes sort of a data application? Well, Snowflake started off as an internal data warehouse, a cloud data warehouse, if you will. But we realized from all of our customers mobilizing all of their data into Snowflake that they could deliver many more workloads than just the internal data warehousing capabilities. And those customers came to realize that, hey, if I've centralized all of my event data, all my log data, and all of my social posts and all of my ERP transactions into Snowflake, then I can build and deliver great applications for my partners, my customers, my suppliers, by building an app UI on top of Snowflake that provides data access to those customers and partners in the form of embedded analytics, or maybe you're doing custom machine learning, or maybe you're doing IoT data processing. All of those things can be done with data apps in Snowflake. There's some challenges, though, when you're building a multi-tenant data applications that's going out to all of your customers instead of just your internal data warehousing users. First, you got to think about how you want to organize and secure the data. This is very important to make sure the right people see the right things in the data. Next, you need to think about how you're going to scale that out to a large number of users. That makes you have to think about how you're going to design your compute in a way that you can handle different workloads and that you can handle peak demand while not overpaying for that compute. You need to think about how you're going to run multiple workloads that don't collide with each other. We want to be able to do data processing without interfering with the data serving that's going on in the application. And most of all, you want to do this with as little overhead as possible because you want to focus on building a great app, not focus on maintaining infrastructure in the back end, designing high availability and DR. All of those things you want to leave to the data platform and make sure that you can focus on building a great app. So all of that is enabled by the Snowflake architecture. Now, I'm not going to do a deep dive on the Snowflake architecture today. That's not really the point of this session, but it is worth calling out some key important aspects of this architecture that are going to help frame the conversation that we're going to have today around tenancy. So first, one of the defining architectural elements of Snowflake is the separation of storage and compute. So as we talk about tenancy today, we are going to talk about it through a storage lens and through a compute lens. And you'll see that as we go further into the presentation. But I should also point out here that last point on the previous slide about you not having to sort of worry about a lot of the infrastructure things under the covers, that's the outer ring that you see here on this architecture slide. We're handling transaction consistency, security and governance, encryption of the data, networking, optimization, management, metadata. All of that is being handled by the Snowflake data platform so that you can focus on building a great data app. And you can do it on whatever cloud that you want based on the clouds that we support there: Google Cloud, AWS, and Azure. So let's talk about the typical tenancy approaches in Snowflake and sort of what are the traits of each one and how you decide on which tenancy model is right for you. So there's 3 tenancy design patterns that I like to outline. Now, these 3 are not, sort of black and white. They aren't the only way that you can look at tenancy, but most everything falls into sort of one of these 3 categories, although you might find some hybrids between them depending on your specific use case. So the first one I kind of referred to as multi-tenant table, or MTT. This isn't necessarily because it involves just a single table or anything, but it's really about how you're going to combine your tenants into common objects. You're going to have them all in one data model being served from the same storage. You're going to have them sharing compute for their query serving. All of that's being done in more of a multi-tenant sort of shared environment. And we'll talk about the difference between storage and compute. The other option is to do object per tenant. Now, this is where we're going to set up different tables or schemas or databases for each tenant, or we're going to set up distinct compute virtual warehouses for each tenant, but we're going to do it all within one Snowflake environment, one Snowflake account. And you can think of a Snowflake account as like a database instance. There's differences, but that's a fairly good comparison. And this object per tenant means that we're really going to focus on, what are the different building blocks that we're going to set aside for each tenant so that they have their own sort of components in the application. And the last pattern I call account per tenant, or APT. And this is where we're going to kind of take an account or an object per tenant model, but we're going to put each tenant into their own Snowflake account to put another sort of layer of isolation between the tenants. And that layer of isolation is going to be a Snowflake account. So these are the 3 different patterns that we're going to talk about today. There, like I said before, these patterns, you can sort of combine them, mix and match them. And I'll talk about that as I go through some diagrams that show this. But the decisions that you make around this are going to be from a storage perspective, a security perspective, a compute perspective, and as well as how customers and users are going to connect to Snowflake through your application. So those are the different angles that we'll sort of assess and analyze this from. So let's kind of dive a little bit deeper on each approach and just talk about some of the common traits. Now this is not black and white. This is kind of at a high level. Not all the traits always apply in every way in every situation, but this is sort of a general characterization of each approach. So with MTT, generally speaking, the tenant data all has the same shape to it. It's the same data model. You have the ability to combine tenants together because all of their tables, all of their schemas, whatever, look the same. And we're not going to do something different for each tenant. And that also means in this scenario that you're likely able to stamp the rows of that common data model with some sort of tenant ID so that you can differentiate one tenant's rows from another. And this is going to be a really important component of MTT because we really need to be able to identify, which tenant has which rows of data. From a compute perspective, we're going to think about how we can pull tenants onto a common compute model and use a common compute model to serve them at scale. And that's going to allow us to gain efficiency in our compute management model and help us control our costs. And because of this model tends to be our highest scaling model, definitely in the tens to hundreds, as you'll see with the other approaches. But this can even go into the thousands and beyond. In fact, I know of 2 Snowflake customers that are in the millions of tenants using this approach. So this is definitely our most scalable approach. Object per tenant, one way that it can differ from the multi-tenant approach is that we do have that unique data shape per tenant. They each have their own data model because you're building a very specific model for each tenant. Maybe it's because it has different sources. Maybe it's because you're doing different calculations and handling different requirements for each tenant, but there could be something unique. It doesn't have to be that way, but that's definitely something that sort of triggers an OPT model. It also means you're not comfortable with row level security and managing entitlement tables to really differentiate that tenant ID row designation that I talked about earlier. But you are comfortable with using RBAC. You are comfortable saying, hey, this tenant user has access to this database while another tenant user has access to a different database. That's all done through RBAC, and you're comfortable with that approach. From a compute perspective, maybe you're contractually obligated, or from a security perspective or regulatory perspective, you want to give each customer their own compute, or you want to give certain customers their own compute, as we'll talk about here in a little bit. And because of you're creating more objects and maintaining more things here, this typically scales in the tens to hundreds of tenants. Doesn't mean that you can't go into thousands, but when you get up into managing that many objects across that many tenants, this approach gets harder. It's not that it's not technically possible, it just gets harder for you to manage. And then account per tenant, this is where you're going to really create that extra level of isolation. You're not comfortable using RBAC to say this tenant gets access to database A, where this tenant gets access to database B. You really want to put a much more firmer connection wall between tenants and put them into their own account. It could be because you also want to use features in Snowflake, like encryption keys or IP allow lists that are typically set at the account level. That might be another reason why you choose this model. It could also be because you want to allow your third-party users to connect directly to the Snowflake environment instead of going through an application tier. This requires the account per tenant model as well. And because of this, like OPT, we're typically talking about scale in the tens to hundreds as well. Again, doesn't mean you can't go higher than that, but it just comes down to maintaining all of those objects and how that works for you. So let's talk about this first from a storage perspective. What does this really look like when we're actually taking these different tenancy models and kind of painting a picture with them? So let's talk about multi-tenant table first. So in this instance, we may have source data. It could be a source data for all, or it could be a source per tenant, but this is coming into our Snowflake environment, and we're going to run transformations on it to put all the tenant data together and stamp it nicely and transform it to the way that we need it to be. And then all of our tenants are going to come through an application tier, and either the application tier is going to inject where clauses, or you're going to use Snowflake row level security to make sure that the orange tenant only sees the orange slice and the purple tenant only sees the purple slice, et cetera, et cetera. So this is where we're going to rely very heavily on row level security or where clauses to control what the tenants see, but they're all going into a common set of objects. This is different than object per tenant, where we're going to create, in this instance, I'm showing it as database, but again, it could be, schemas, could be tables, whatever, but we're going to create a database per tenant. And in this database per tenant, we're going to have our source data coming in, and that could be, again, one source that's fanning out into different tenant databases, or it could be that we have a source per tenant and we're going to route that specifically into that tenant's database. But in the application tier and through Snowflake security, we're able to route the orange tenant to the orange database, the purple tenant to the purple database, the pink tenant to the pink database. So that's what we're doing in an object per tenant model. In an account per tenant model, we're just going to draw an account wall around that tenant database. So we have data that's coming in. Again, we can either be fanning out or have a source per tenant, but these are going into individual accounts, and there's a database in that account for that tenant. And we could have our tenants connecting through the application tier, as we see with orange and purple, or in the case of pink, pink is actually connecting to the Snowflake account directly, maybe bringing their own tool like Tableau or an ETL tool, or it could be because they're going to actually use the Snowflake UI. Now, one point to make here about how that source data gets into the account, there are actually two ways. The first way is you could actually do a direct ETL load into that account. So those blue lines that you see, or blue arrows that you see there, could be actual sort of data pipelines, data feeds. But they could also be data sharing as well, where you as the account, the app owner, have your own sort of central Snowflake account, and you're sharing the data from your central Snowflake account out to the individual tenant accounts using data sharing. In that instance, the data doesn't get copied into the account per tenant. Those tenants are actually just reading a live read-only database through that account. So some Snowflake features that you should be aware of that sort of go hand in hand with how you design your storage. First is our variant data type. This allows you to do schema on read instead of schema on write. So you can actually put semi-structured data into a single column within Snowflake. It can contain as many attributes as you want, and those attributes can change row by row. And this allows you to have a much easier pipeline to write, as well as pipelines are going to fail less, because one of the common pipeline failure problems is when source systems change and now the target schema doesn't have the structure to match what's coming in from the source system. You won't have those failures anymore if you're loading data into our variant data type, because we can handle that data drift nicely. Our table clustering capability organizes the data around certain keys. And when you're using the multi-tenant approach, you're going to want to organize the data at some level by tenant. You may have other keys that you want to include with that as well, but at minimum, you're going to have tenant as part of that composite key so that it makes it really easy and fast to prune data away, because all queries are going to come through with some sort of tenant where clause on them. And we want to eliminate micropartitions that we don't need to scan. And our auto clustering service will help you keep a table in its natural clustering state. Materialized views might be useful to you to help you with your pipelines, to aggregate data to the highest level possible to make your queries run fast. And because of the automatic nature of our materialized view service, those will refresh in the background and decrease the amount of pipeline overhead that you have. And then lastly, data sharing, which I'm actually going to talk about in another session here during the summit. But this allows you, as I mentioned before, to grant that read-only access from your account into another Snowflake account. It could be one that you own that you're providing for your tenants. It could be that your tenants own their own Snowflake account and you're going to share the data directly out to them. And that helps you to offload some workloads, as well as when they need access to bulk data, you don't have to build incredibly robust APIs for your tenants to be able to go and call and download millions or billions of records of data through an API layer. That's just not scalable. So using data sharing is a great way to handle those scenarios. From a security standpoint, we have, as I mentioned before, that dynamic data masking allows us to mask data from a column perspective. Our row level security allows us to do it from a row perspective. And this is allowing you to secure PHI, PII data from your developers, as well as making sure tenants only see the data they're supposed to see. And from a role-based access control, I mentioned this before, this is where you can put fine-grained control over who can see what objects in the system, including compute. And creating a good hierarchy of those privileges is a good thing to do in your role-based access control design. And then lastly, our Tri-Secret Secure feature allows you to have more control over the encryption keys that are used to encrypt the data in Snowflake so that you can very easily pull the plug on access to data in a pinch if you need to. So let's talk about optimizing compute now and looking at the same sort of tenancy categories, but through a compute lens instead of a storage lens. So again, going back to our sort of typical 3 design patterns for tenancy, when we talk about multi-tenant table, it's not really table anymore. We're talking about multi-tenant compute. And what we mean here is that tenants are going to share compute. And again, this compute is what's going to run their queries within Snowflake. So you can see here that orange, purple, and pink are sharing one virtual warehouse. We're going to call that virtual warehouse or pooled compute A, where teal and dark blue are sharing B. And the nice thing about this is that the compute model that you choose for tenancy can be different than the storage model that you choose. So in the instance of B, we actually have teal and dark blue routing to their own database, even though they're sharing the same compute to run their queries. Where over on compute A, we actually have orange, purple, and pink using the multi-tenant table approach. Now, generally speaking, you're probably going to pick, you're not going to have this sort of everything going on at one time as I'm showing in this diagram. But what's important here is to highlight that you can mix and match models between storage and compute. And this is even more illustrated on our object per tenant model, where we're going to start to give more tenants their own virtual warehouse, their own compute. So you can see here, orange and purple have their own. That might be because they're special customers, they're paying for a higher level of service. Maybe we have a special contract with them. But again, we can have whatever storage tenancy model behind the scenes that we want. In this case, orange is going to their own database, where purple is part of a multi-tenant storage approach. And in this instance, we also have pink, teal, and dark blue sharing compute while purple gets its own compute in that scenario. So again, that sort of ability to mix and match allows you to build these sort of hybrid scenarios. However, when we get to account per tenant, this is where we start to get locked down a little bit more. And that's because compute does not span accounts within Snowflake. So when you're using the account per tenant model, you're actually going to be forced into giving each tenant their own compute, their own virtual warehouse. So now within that tenant account, we're going to see a dedicated tenant database and a dedicated tenant compute. And no one's going to share anything in this scenario. There's not going to be any pooling of anything. Again, all of our source data can come in all of the same ways that I described before. And from an access perspective, we can still have tenants going through an application tier, or we can have them going directly against the Snowflake account with their own tools or logging into the Snowflake UI. But the difference here is that sort of dedicated compute for each tenant within their own account. So some features that are important for you to understand when thinking about compute. First, you need to understand Snowflake scaling. We have two different kinds of scaling. We have vertical scaling, which is the size of the cluster, the amount of horsepower that you're going to bring to process queries. We have t-shirt sizes from extra small all the way up through, I think, 6XL we recently introduced. And this is just going to make workloads run faster. And it's also going to give you the flexibility to right size your workloads. So some workloads might only need a small where other workloads need an extra large, and you can right size your compute with the size that you pick there. And then horizontal scaling is going to allow you to handle more on a given virtual warehouse at the same time, more concurrency, if you will, because what happens in our horizontal scaling is that a given compute will spin up clones, or we call them clusters, as in a multi-cluster warehouse, of itself when more demand comes into the system based on a configuration that you set. We'll spin them up automatically when that demand comes in. We'll spin them down automatically when that demand goes away. And that allows you to be more elastic and handle, your peak loads without overpaying for idle resources. And then the beauty of Snowflake is you can create as many of these virtual warehouses as you want. And so you can isolate workloads on them so they don't contend with each other. You can have a compute that's dedicated to ingesting data, a virtual warehouse that's coming in and doing all the transformations on the data, and then another one for serving that's going to allow all of your tenants to query the database. And none of those will collide with each other from a resource contention perspective. And then, of course, you're going to put resource monitoring on all of the compute nodes that you can create so that you can manage your costs. And then securing this compute, we have two options. We have our use function, which allows you to select which warehouse is going to be used, assuming that the user has permissions to use that warehouse. We can also set a default warehouse per user, and this allows you to sort of auto direct traffic, as you will, as users connect to Snowflake, instantiate a query, it'll automatically use the right warehouse that you want it to use based on that default warehouses. We can set network policies on accounts or on users. So if you set them on a user and you have a user using a default warehouse, that sort of by proxy allows you to set a network policy on a warehouse and gives you more security for your data application. As well as you should understand when you're thinking about pooling tenants on compute that the warehouses do cache data. And so you should be aware of the fact that, if you've got multiple tenants sharing compute, that their cache will reside on that compute node. Now, cache is secured in the same way that the underlying data is secured. So you can be sure that everything is secure all the way up and down the stack, but it's important for you to know and understand that that exists. Okay, so let's kind of think about our key takeaways, and we're going to do this through two different flowcharts. So first, we're going to look at a flowchart from a storage perspective and think through what are the sort of questions that I kind of ask myself and how do I answer them as it relates to what tenancy model is the right for me. So thinking about this from a storage perspective, I want to build an app on Snowflake. One of the first things you're going to think about is, do you have strong legal isolation rules? Maybe that's because of the industry that you're in. Maybe it's because of the contracts you have with your customers. Maybe it's for some other reason, but do you have, some overriding arching governance body that's sort of going to dictate what is okay and what is not okay? If you do have that, then you have to start to ask some questions. Is encryption per tenant required? Is RBAC enough for me to isolate tenants? Is row level security enough for me to isolate tenants? Depending on the answers to those questions, will direct you to a certain model. So APT, for example, if I need encryption per tenant, or if I'm not comfortable using RBAC, that's going to direct you down an APT approach, where if I can use row level security, that will probably direct me down an MTT approach, where if it's not okay, but RBAC is, I'm going to go more the OPT route. That's sort of the first lane you can think of from a flowchart perspective. But back to our strong legal isolation rules, if I don't have those, then I can start to ask myself other things. Are tenants going to bring their own tool? Do they need to log into the Snowflake UI? If that's the case, then I'm going to set up more of an account per tenant model, because that's the only model that we support that capability through our master service agreement. So that is the model that you're going to choose if that's a key component of your data application. But if those two really don't come into play, Then you're going to kind of go back to, what am I more comfortable with? Is RBAC enough for me to isolate tenants? Am I comfortable with row level security? What is the scale that I'm trying to support? All of those things are what you're going to ask yourself when figuring out what's the right model for you, as well as are the data structures unique per tenant? Because that's going to direct you into an OPT approach as well. So looking at this from the same thing from a compute perspective, again, I want to build an app on Snowflake. The first thing you're going to ask yourself here is, well, did storage dictate something for me? Do I have strong rules that I have to follow that were decided on from a storage perspective? Because if I do, I might be forced down an account per tenant model, for example, if storage dictated that. What do I need from a network policy? How do I feel about tenant cache on shared compute? Those are going to direct you down different paths as well. Thinking through this further, do I need to evaluate, and measure strict COGS per tenant? We didn't really talk about that in much detail, but it's much easier to know the cost of each tenant when they're using their own dedicated compute. Doesn't mean you can't calculate it when they're sharing. It's just a little bit harder to do the heuristics in that calculation and develop an algorithm that you're happy with. Do you need to prevent tenants from colliding with each other? That might be another reason you need to separate them out onto their own compute. Or if it's okay that they're sort of managing access to resources and you don't have rigid SLOs around that, you might be okay with an MTT approach. And then, of course, we're also going to look at, whether they can bring their own tool and whether they need to log into the Snowflake UI as well. Both of those questions kind of recur here in this flowchart and take us down a very specific path. Otherwise, it's really just sort of evaluating, if you don't have strong legal isolation rules, what are your other factors that are going to sort of drive your decision there? All right, so hopefully showing you all those different tenancy patterns and how you can think about them from a storage and compute perspective, and then kind of walking through those flowcharts at the end was a good way to educate you on the different options that you have when building your data application. Thanks for attending this session and enjoy the rest of the summit.